Assalamualaikum everyone. For question one, I was tasked with sketching the overall system architect. The core of this system is data flow. It starts with the four rapid sensor which detect passenger from press, press, passenger crossing the yellow line. The analog signal are converted into digital data by ADC or analog to digital converter. The digital data servers has two purposes. First, it goes to the passenger detect logic block, which is a simple circuit that check if more than three sensors are triggered at once to the sound the alarm. Second, it increment the main synchronous counter, which keeps the total count of people on the platform. And then the counter value is critical. It is sent to a DSA to convert it back to an analog voltage for the control room display. And it is the primary input for the final state machine or FSM. The FSM is the brain of the operator. It uses the counter value to decide whether to keep the gate open or closed. Transaction between its ideal check, open and close stages. Finally, the 555 timer provides the clock laws that synchronize everything, the counter, the FSM, and the logic, ensuring the inter-system operator is a coordinate manner. And for question 2, I have to solve or I have to design the logic for the final state machine that control the platform gate. The FSM has four states. It start in IDLE, waiting for activity when the counter is greater than zero. If it moves to check, then in the check state it decides the next action. If the platform is full, meaning the counter has reaches 10, it goes to close the gate. If not, and then it goes to open the gate. The system must also close after 20 tickets are issued for the day. So while in the open state, it waits for a special down signal from the counter. Once the down signal is received, it transitions to the closed state and finally back to ideal. I then translate the logic into Verilog HDL code. The code defines the state, use a block to handle state transition on the clock edges, and a combinational block to define the output, which is simply to open the gate only when the FSM is in the open state. This creates a clear, reasonable control flow for the game mechanism. For question three focus on the immediate safety feature, triggering an alarm if more than three people cross together. Since we have four sensors, the condition for alarm is simple. It must trigger only if all four sensors are active. The Boolean expression for this is a four-input NAND gate. AND gate. LM equals A and B and C and D. The requirement was to implement this using only NAND gates. Since a NAND gate is a universal gate, we can build any other logic function from it. To create an AND function from NANDs, you simply inverted the output of a NAND gates. So I designed a circuit when the four sensor signals are fed into a signal four input NAND gates. The output of these gates is then fed into both inputs of a second NAND gates, which act as an inverter. This final output gives us our alarm signal, which is high only when all four inputs are high. And then for question 4, I have to use my ID. For the 555 timer circuit, I first calculate the necessary value based on my student ID. The sum of my digit is P and P was 25. This gave me a target frequency of 255 Hz and a duty cycle of 75%. And where R1 is 56.48 ohm and R2 is for capacitor 50 50. My R1 is 56.48 ohm and R2 is 11.29 ohm. Sorry, for C1, R1, my R1 is 56.4 ohm, and for C2, my R2 is 5.65 ohm, and R1 is 11.29 ohm, and for C3, my R2 is 3.00 ohm, and R1 is 6.00 ohm. I also generate a circuit for this. And for question 5, the question 5 asks us to show how the DSA converts the digital passenger count into an analog voltage. We have 4-bit DSA with a 5-volt reference. This means it can replace 16 different values from 0 to 15. The resolution or the voltage change per step is calculated as the reference voltage divided by the number of steps. So 5 volt divided by 16 give us a step size of 0.3125 volt. For 5 passenger, the digital input is 5. So the output voltage is simply 5 multiplied by 0.3125 volt, which is equal 1.562 volt. And for question 6, they ask us to limitation of the system. Finally, while the system is functionally sound, it has several significant limitations for real-world engineering perspective. First, it lacks a mechanism for counting people, the platform. The counter only increments, so after 10 people enter, the gate would never open again if everyone leaves. Second, it relies on perfect RFID readers. In reality, signals can be blocked or missed, leading to an incorrect counts. Third, the alarm log is too simple. It assumes people will work in a perfect single file. A group of 3 working closely together might accidentally trigger a fourth sensor, causing a false alarm. Also, using a simple DSA to send data to a control room is to noise and signal degradation over long distance. A digital communication method would be more good for this. Finally, the ability of 20 ticket daily limit is not practical for a public transport system and highlights that system logic is too unreal for a real world passenger flow. A more flexible and fault tolerant design would be necessary for an actual development. Thank you, everyone.